Hello, physics class. Today we'll be learning about chapters 8 to 11 of mechanics.
Vectors are a way to mathematically represent displacement, velocity, and force. They are defined quantities that also include direction.
Now, scalar measurement is a medium strictly in magnitude, such as time or temperature.
A vector could be anything like velocity, acceleration, or force. To show direction, a compass could be used.
Here we have Rochelle as the x, Emily as the y, and Vera represents the resultant vector.
Adding, subtracting, multiplying vectors consists of working with the x and y components of the resultant vector.
The way we add vectors is using the component method. This is which you decompose a vector, so find the x and the y values, add or subtract them together, or multiply them together, and then you would add those together and create a new vector which you would find the direction that it is.
Also describes the rate at which position changes. Velocity v is equal to displacement delta x over the time interval delta t. A velocity time graph to an acceleration time graph, you'd also find the same.
This is an example of displacement, position, and distance traveled. Kyle will make his way around 20 meters of his field. His final displacement, however, will be 0 because he will return to the origin.
Displacement, which is represented by delta x, is defined as the change in position. So if something moves from one spot to another one, its displacement would be the difference.
Mass displacement occurs along the y and the x-axis simultaneously. Watch as he accelerates due to gravitational acceleration.
Distance, usually represented by the symbol L, is the length of a trajectory without taking direction into account. A trajectory is a series of successive points through which an object passes through. Position is defined as the location of a point or an object on a graph. I'll also explore uniformly accelerated irregular motion. In this type of motion, velocity varies regularly from one moment to the next.
Michelle is displaying uniform rectilinear motion. Now she's displaying uniform accelerated rectilinear motion.
Matt is walking at a constant velocity. His velocity is changing and he's accelerating.
Oh, kill him! Oh, kill him! Oh!
It's accelerating.
Yes.
Look at her run.
Investigate in the uniformly accelerated auxiliary motion a velocity time graph. We can either discover its average velocity or the instantaneous velocity. The graph of position as a function of time, the instantaneous velocity corresponds to the slope, the tangent of the curve at a precise point in time. While average acceleration corresponds to the change of velocity delta v divided by the time interval delta t. We have established 4 equations that describe the relationship between acceleration, position, velocity, and time, and initial and final time. There's variables ti, tf, which are initial time and final time, xi, xf, initial position, final position, vi, vf, initial velocity, final velocity, and a, acceleration.
A projectile is a curved motion that follows a trajectory.
Push me, mommy!
Okay. Kyle's initial position is his highest peak in his swing because it is then that he begins his trajectory toward the ground. The water bottle Emily is holding will attain its maximum range because it is being shot at a 45-degree angle.